So you have your graph that looks something like this with your energy on the y-axis, and that is firstly a representation of your bond energy. So if you asked to find your bond energy, you know you're going to have to go to this axis. And then on your x-axis, they're telling you the distance between the nuclei. Now what that means is, if you've got these two atoms coming closer to each other, if I take a ruler and I measure between the nucleus of one atom to the other, this is going to be the distance between its nuclei. Right, so if we read the graph, firstly it has a shape that looks something like this. Right, and what is important about this graph is, if we read going in this direction, what we see firstly is that the distance between the nuclei is decreasing. So if I'm reading going in this direction, the atoms are basically getting closer and closer to each other. Eventually they get so close to a point where the attractive forces, which is between the nucleus and the electrons, are going to be so strong that it's going to now form a chemical bond. So if this graph is complicated, the most important point for you to make note of is this lowest peak point here, right? This is an important point because this is where your chemical bond forms. Okay, your chemical bond forms, and a description of that is basically you have the lowest possible energy because now everything is stable. Your atoms have reached stability, therefore they're bonded. If they ask you to actually write down what is the chemical bond, or they ask you to write down what is the bond energy, how you read that is, firstly, which axis is telling you energy? It's your y-axis. So it's all the points on the y-axis like this. So you'll take your ruler and you'll measure from that point to your y-axis and you'll read off that value. That is going to be your bond energy. Okay, and then they can also ask you what is the distance between the atomic nuclei. So where are we getting the distance? It's going to be our x-axis. So again, you take your ruler and from this point, you draw a line upwards to the x-axis and you read off that value. That is going to be a special name. We call it is the bond length. Okay. Alternatively, they could actually ask you what is the bond length, like where is it located, and you need to be able to tell them. So those are two of the important things we can get asked from this graph. The other part of this work is mostly theory based, so we're just going to briefly go